Okay, we have this one sample t-test problem. So according to report by Quartz in 2013, the Philippines is the #1 coffee consumer in Asia. The typical Filipino drinks an average of 0.608 cups of coffee per day, which is equivalent to an average of 4.256 cups per week. Suppose that a sample of 12 senior citizens revealed they consumed the following number of cups of coffee during the last week. We have 3, 2, 4, 4, 5, 7, 7, 5, 5, 3, 4, 4. At the 0.05 level of significance, do the sample data suggest that there is a difference between the national average and the sample mean from the senior citizens? Assume that the population is approximately normal. Okay? So in here, we are going to follow the 5 steps in hypothesis testing. Okay? We have the first step. We identify the null and alternative hypothesis. So the null hypothesis here is we're going to consider the average per week, which is this one, 4.256. So the population mean is equal to 4.256 cups per week. Or in sentence, it is stated as there is no significant or there's no difference. So there is no difference between the national average and the sample mean from the senior citizens. Okay, that is the null hypothesis. Okay, for the alternative, since the clue word here is there is a difference, meaning we use the not equal sign. So that is, the mean is not equal to 4.256. So step 2, we're going to identify the appropriate test statistics, right? As you can see, we have unknown population standard deviation, right? Population standard deviation is unknown. Then the sample size is just 12, which is less than 30. So therefore, we use the t-test, okay? So the test statistic that we're going to use is the t-test, okay? So the third step is we're going to compute the test statistic. Okay, so we're going to use the formula T is equal to sample mean minus the population mean over the standard deviation of the sample square root of n. But as you can see, we do not have yet our sample mean and sample standard deviation. So we solve our first mode 3, then 1 var. We just enter the data, that's 3, 2, then 4, 4, then 5, 7, then another 7, then 5, 5, 3, 4, and 4. Then we compute. So shift stat 1, then we press 4 variants. So the mean we press 2. Okay, equals. So 4.416 or 4.42. Okay, so therefore we're gonna use the mean as 4.42. And for the standard deviation of the sample, shift 1, then 4. Press 4, that is 1.51. So 1.51. And our n here is 12. And the population mean is 4.256. Okay, plugging in these values in the formula, we now have T equals 4.42 minus 4.256 divided by 1.51 over square root of 12. Okay, so T equals, so 4.42 minus 4.256 divided by 1.51 over square root of 12. Okay, that is 0.376. Okay, 0.376. Okay, that is our value of the T statistic. Okay, what we're going to do next here is we find the critical value. Okay, step 4. So we have alpha is equal to 0.05, and the alternative hypothesis use not equal. So this is a two-tailed test, right? Two-tailed test. Then what we are going to do here is to find the degrees of freedom, because we have T, so n minus 1, and that is equal to 12 minus 1, which is 11. So we're going to find the value, the critical value at DF equals 12 and at alpha 0.05 for the two-tail. Okay? So alpha is 0.05 for two tails. So this one, this is 0.05, two tails, then 11. So here, right? So 2.201. 2.201. Okay? So therefore, the T critical value equals to so 2.201. Okay, next is we are going to compare for our step 5. So the T compute. So if the T computed for the T statistics, is the absolute value is greater than the critical value, we reject HO. So otherwise we accept. So our T here is 0.376. This is less than, right? 2.201. So what is our decision? We fail to reject HO. So what conclusion can we make? There is no significant difference or no difference between the national average and the sample average or sample mean. Average and sample mean can be used interchangeably. Okay, so that's how to use one sample t-test.